So there are a number of different ways one can form methane on Mars. You can have methane actually coming in with the comets or meteorites that strike on Mars. The other two ways, which I think are most likely, is to produce methane in the interior of Mars, and that's by reaction between water and rock. And what happens in that process is when that reaction occurs, hydrogen is released, and that hydrogen then combines with what we call as primordial carbon, which is there in the rocks or is in the environment, and in turn produces methane. The other process that occurs in the interior is, of course, by biology, in which case the microbes use hydrogen or carbon dioxide or the combination of the two, and then as nutrients, and in their metabolic process they release methane.
There's never been any distinct evidence, and there's never been evidence tied to a specific locality, and I think that's the difference here. We finally know where to go. We can start to frame more sophisticated questions. We can go in with the right set of instruments, or we can position the orbiting assets to look in greater and greater detail at these specific regions. So that's what's new here, that's what's different. Oh, absolutely. And in this case, we're talking about organisms that can either produce or consume methane, which are among the most ancient on Earth. When we know that the pathway is possible for an organism on Earth, then we can be more confident that the pathway metabolically would be possible for another life form on another planet.